All right, well, welcome everyone. Let's get right into it. My name's Matt. I'm really excited to have a chance to share all this great stuff with everyone here. And look, my point of view on all of this is we're all here to learn together. GraphQL is a really new technology, and everything you're going to see from us and everything I know came from working with teams that are building amazing stuff. So please don't take this as an event where you came, we're going to tell you a bunch of stuff, and then you go home. It really isn't that. And I'm really excited to learn from everyone here and find out more about what everyone's doing. Let's start by assuring everyone that you're in the right room. So this is a look at how GraphQL adoption has progressed over the last few years from Google Trends, and we're sitting it next to some of the other ideas like Falcor or OData that tried to structure how an API might work. And the point is it's happening. This has all the makings of a developer megatrend. I think something north of 80% of JavaScript developers, according to the State of JavaScript survey last year, said that they're using or want to learn GraphQL. North of 20% of all Node developers, according to the Node Foundation, are actively developing GraphQL APIs. Lori Voss of NPM talks about GraphQL as one of the absolute must-learn technologies for 2019, so on and so on and so on. So, you know, this is new, but it's absolutely up off the ground. And one of the things we're going to try to do today is help you gain more confidence about not just adopting GraphQL, but going faster and further, maybe than you were otherwise planning. And I think part of having that confidence is seeing the momentum and the proof points across the industry of what people are doing. We get a bird's eye view of a lot of that at Apollo because of our open source work. One of the things we built early on is Apollo Client. This is the library that binds your UI to your GraphQL schema. That looks about right. So what's driving all this? You know, GraphQL isn't like Yarn or Redux, something you might reasonably implement in a day or two. It's an API. We're talking about an API that's displacing REST as the link between your apps and your services. So it's a lot to adopt something like that, and the benefits have to be commensurate with that. And I think we all know a lot of the story. It's less data on the wire, it's great tooling, we're going to see some examples of that, but I think the story goes deeper than that. And to illustrate what I'm thinking about, we might look at a kind of modern app experience. Here's sort of your hypothetical hotel booking app. And what we hear over and over and what we see is a modern app means data. A modern app experience means connecting users with a growing array of different bits of data that create the experience they have. Whether it's personalization or machine learning and recommendations or real-time pricing and inventory or something social or something that's streaming into the user experience. Great experiences depend on being able to bring all the data you have into one screen. And that data lives in a growing array of places, right? With the rise of microservices and cloud-native architecture, this information doesn't come from one database or one endpoint anymore. It comes from 3, 4, 5, 10 different systems that you may be running in your environment. And if you'll excuse the crude drawing, that's one of the trends we see. There's another thing happening at the same time, which is the expectations of our users are now that the applications are on a growing array of platforms. It's not just web and mobile anymore, right? We also have IoT, we've got CarPlay, watches, voice, and something coming next year that we don't know about yet, but when it emerges, we're going to have our applications and our experiences on that platform too. And all of that is against a third trend. There's a backdrop against this, which is the government is starting to take an interest in this stuff. And so the way that data moves from the cloud to our apps is now governed by GDPR, by the California Consumer Privacy Act coming next year. And we're going to have to start having a structured understanding of exactly how our data moves and exactly what we're doing with it. And so the question is, how on earth are we supposed to build great apps quickly when we've got all these services, all these things that we have to build, all these connections between the two that are governed by these rules that most developers don't want to know about and shouldn't have to know about. And the way out of the mess, in our point of view, is this new layer in the stack, the data graph. And when we talk about the rise of GraphQL and the adoption of these ideas, most of that is in the context of this concept, where we're going to use GraphQL as a way to decouple the services that we run internally, where all the business logic and the data and all that investment we've made lives, from the applications and the user experiences that we need to build going forward. You can think of it as a marketplace, right? The applications describe declaratively the data they require in the form of GraphQL queries. Services describe their capabilities in the form of a resolver, right, in a schema. And what we put in the middle is this Amazon Prime for all your data, right? I don't have to know where it's going to come from exactly. I don't have to know about all the logistics that live underneath that to be able to take advantage of this idea that as a consumer of data, I just describe what I need, just like I go order some stuff from Amazon, and it shows up exactly the way I asked for it without any complication. And there's so many compelling ideas to this, I think. So development velocity goes without saying. You're not writing all those individual APIs. You're not building all of that point-to-point connectivity between each app and each service. We call that the M by N problem sometimes. You get consistency, so things can live in the data graph like localization or internationalization that you used to have to write individually in each client. Now you get to write it once, and it's the same for everyone. And I think maybe most exciting, for the first time we have this central view and control over how data moves around the organization. This fine-grained understanding of exactly what data each client needs, exactly what data it's using and not using, exactly which part of a service's API is actually finding its way to your user, and how, and in what setting. And we're going to see some examples of how powerful that is and how exciting that can be for app development. The other cool thing about the data graph is you can start really small. So our recommendation, and what most teams do, is just start with one screen in one app and just one service. And your graph is nothing more than one or two GraphQL types and a few resolvers. It's that simple. There's good news and bad news here, though. There's a really strong network effect around that graph. What inevitably happens is, as soon as you stand one up, the adjacent mobile application wants to consume the same graph, and it might only need an extra field or two in the schema to do that. And that enables you to bring in a new service that brings in a new piece of data that allows you to move more components from your web app over. You're not going to end up with 10 of these things that are really little. You're going to end up with one big one. And that's the challenge, and a lot of what we want to talk about today is fundamentally what we hear from teams that are adopting this, if I can distill it all down to one point, is I know I'm committed to GraphQL. My developers are going to quit if I don't do it. And I see the benefits of centralizing all this into a schema, but I know there's a lot at stake because I know I'm going to end up with one. And the idea, for example, that all my developers, 200 developers, are going to collaborate on a big node thing in the middle of my stack is nuts. So I want to know that I'm architecting the schema right. I want to know that I have the right patterns for how I connect my services to my apps. I want to know that I have the right development process and collaboration in place. I want to know that the right team owns this and that I have the right process around how it changes and how it evolves over time. And to answer some of that, my co-founder Jeff and I wrote a document. It's at principledgraphql.com that distills what we've learned from hundreds of conversations with teams, startups, enterprises, all sizes, and captures the best patterns we've learned about how best to architect a graph, what it looks like to have an agile development process around that graph, what it looks like to have a thoughtful approach to DevOps and management and monitoring of this stuff. And I'm not going to go through all of these today, but we are going to touch on some of them as we go through the day. And the reason I put this up on the screen is these principles aren't just something we made up. They're a roadmap They're a roadmap for you as you're adopting GraphQL that can help guide you down the right path for how to build this out from step 1 to step 2 to step 100. They're also a roadmap for us in terms of what we build to support you, the products and the open source libraries and the tools and the guidance and all that. It all comes from these core ideas. So I'll show you a couple examples of what we've done so far. This is one of the features in Apollo called schema change validation. The idea here is you want to have an agile process around your graph. That means you're going to need to change it. You're not just going to keep adding more fields to it. You're going to want to prune it and evolve it as your product needs change. And if you have that ability, it gives you great freedom to move quickly as you start building because you don't have to worry about making a mistake. One of the benefits, turns out, of GraphQL is that it's very light on its feet. It lets you be quick with your development cycle. So here's an example of why having this fine-grained understanding of data can be so powerful. With GraphQL, we can validate at build time whether a proposed change to your data graph is compatible with all the clients out there that are consuming the graph. And we can do this algebraically. We have precise knowledge of every query that's been run in production, and we can couple that with the proposed change. Say you're removing a field or you're changing something about an input type, and essentially enumerate all of the clients that are affected by that change. This gives you a process now for either pushing that anyway because it's an old client and you're not concerned, talking to the correct team, maybe deprecating the field instead of removing it outright. There's a whole set of workflows you can build around this. And some of this stuff is obvious, like you're not going to delete a field that's being used, but it's actually pretty sophisticated. This is taken from our documentation for schema change validation. There are some interesting cases around what if you change the structure of an enum type, or if you make an input type required that wasn't previously required. That's safe in some cases, less safe in others. So the point is we have this really sophisticated understanding, way beyond what we ever had with REST APIs, of how we can evolve this graph. Here's another example. We have a plugin for VS Code. This has gotten really popular in the client community. You get the basics, things like autocomplete. Let's bring in the documentation string so you can see what's in the scheme as you type. But it goes way beyond that. For example, we can show the predicted performance of a query. Is this thing I'm typing, which I've never used in a product before, fast or slow? Does adding this field, is it basically for free? Or is it expensive because it turns out behind the scenes that's coming from a whole different service and that changes the whole query execution model? So this empowers developers as you're building product with a level of understanding of the consequence of what you're building at build time, right? As you're just in this phase of first experimenting with a new product shape. Or a third example, safe listing. I can type any arbitrary GraphQL query. I can develop software 10 times faster. That's awesome. The idea that I'm going to put that thing on the internet and anyone can type a GraphQL query, that's less awesome. So there's a pattern we recommend called safe listing where as part of the build cycle in your CI toolchain for your client, we actually extract the queries that you've written, register those, produce a manifest, and have the server use that manifest as a yes-no condition for incoming queries. So we've now crunched down in production your use of GraphQL to a set of understood RPCs that you've validated in the development cycle and that you can have in production. Okay, those are some examples. They're all based on this core Apollo platform, and I'll just speak for a moment about what it is that we've built and what it's for. So the central part of Apollo is a set of open source libraries and tools that implement GraphQL. So we have a server, of course, and a client for both JavaScript and for mobile, along with some associated libraries and tools. What we layer underneath that is we call it a graph manager. So a set of registries that run in the cloud that track your schema and how it changes over time, which clients you've registered, what the operations in those clients are. And a set of analytics that are specific to GraphQL so that, for example, we can do schema change validation by knowing which queries had run and therefore replaying those against the proposed change in the graph. And then on top of that, you can build a lot of workflows, not just schema change control, but access control, and some more sophisticated stuff at enterprise scale around rolling out large changes to graphs with many developers. Okay, we'll talk more about this over the course of the day. What I want to do is look forward. and set the stage a little bit for what you're going to hear from James and from Peggy and others over the next couple hours. So there's two big ideas that we've been working on that we want to share and have a discussion about. The first one's federation. So this is about architecting a data graph for scale. It's so important. When we talk to teams, especially larger teams that are going down that path where they're starting with a small graph and they're getting bigger and bigger, here's the thing we hear over and over again. They've put something into production, and it's actually usually something pretty important because you want to prove the value of the technology right away. So maybe it's the booking page, or maybe it's the checkout flow for an e-commerce store. And the experience has been great, and so the goal is now to expand to that org-wide data graph because the benefits are clear. And as I said, we're going to want one big one, not 10 little ones. But how are you going to do it, right? You're not going to have 100 developers pushing code into a Node app. You need something more scalable, something that has more reliability, more structure, more process, something that allows teams to move in an independent way. This has been a topic in the GraphQL community for years. We published a library called Schema Stitching some time ago that was one approach to this. Turns out not to be the right approach. We'll talk about more of that in a moment. But for the last 6 months or so, we've been working on something we're pretty excited about called federation. We've been working with teams from New York Times, Airbnb, Expedia, and other companies on an architecture for taking a graph not as a monolith, but as something composed from parts. And it looks something like this. So that layer that we put inside of our environment between our apps and our services, we're actually going to break into two parts with separate responsibilities. So we're going to have a set of microservices, not just one, but a whole set, each of which is responsible for defining a portion of the graph. We might have a product team, we might have a user accounts team, we might have a reviews team. And this architecture is designed to align with the teams you already have. So you probably have microservice owners that are responsible for different parts of your data ecosystem. What we're looking for here is an architecture that lets us align the data graph with that structure so that the experts at each of those domains are responsible for their parts of the graph, the types, the fields, the mutations and such that are specific to that. And there's a lot of, there's some cool stuff in here. James is going to show you a lot of that in a moment. The other half of the story is a gateway. This is your shared infrastructure. There is no user code in this gateway, is an important part of this design. This is where centralized management, metrics and analytics, policy enforcement, safe listing, for example, the idea that we're going to push a manifest of what's allowed and not allowed, all that is about the graph as a whole. So that lives in the gateway. And so this architecture allows you to have a shared piece of infrastructure, just like you might have a shared Kafka deploy, right? That is the foundation of your overall graph, but then the actual definition, the schema, is the result of individual teams working independently on individual graph microservices. And if you pair that with the platform, the stuff I was showing you earlier, things like schema change validation, safe listing, and so on, you end up with something that's really, really interesting. And the workflow might be something like this. When the product team, on its own schedule, its own sprint cycle, wants to make a change to their part of the data model, they might push an update to that product microservice. That's going to trigger a recomputation of the whole graph. We're going to validate that, by the way, so we're going to make sure that that new graph is compatible with all the use cases. And then we're going to push that into the gateway. And now all of the applications have the new fields or the changed part of the graph available to them. And then maybe a day later or an hour later or a month later, I don't know, the user team does the same thing. And the point is these things are happening independently. So there's a way to operate at this local scale where the team is responsible just for its piece. And you don't have to know about all the different parts of the graph that you're not responsible for. And you don't have to know about all the clients or the consumers of the graph that are using your data, not directly anyway. You just have the structure in place so that as you make changes to it, those changes are validated, pushed into production in a seamless way. Your gateway flips over from one configuration to the next. Clients are none the wiser because you're always making backward compatible changes, or forward compatible, I should say, as you make these changes. And you end up with the holy grail of sorts. You have a single data graph, but a federated implementation of that graph. So that's the first big idea we're going to talk about. We are releasing in just a couple of weeks the implementation of this, and everything in this picture on the left, the gateway and the microservices, is all 100% MIT open source. I'm told that if you come talk to us today, we will get you an advanced copy of that. So we do have people running this stuff, and we'd be really excited to get your feedback on it. And along with that comes a whole ton of documentation about the programming model and how you describe a graph in this way where the two parts can be joined as I described. So James is going to walk through all of that in just a minute. We'll do that interactively. Please pepper him with questions, and we'll get you a copy after the show. Okay, second big idea, and I'm really excited about this, is I think what's emerging is I'll call it a new modern stack. And if federation is about graph architecture, this idea is about using the graph. And I think, how many people here are product engineers working on React or something like React as part of your role? Yeah, a lot of the audience. And we typically see GraphQL as first adopted by product engineering teams because the problems it solves are so product-centric that it's the fastest way to something that's valuable. And I think everybody knows some of the benefits. We've seen tooling. We've seen you don't have to write as much code. Maybe fewer bytes on the wire is important, especially for a lot of teams on mobile networks. But I think there's a lot more to the story that hasn't been told yet. And one of the things that GraphQL lets you do is it lets you take a unified approach to managing all the data in your app, not just the data coming from the cloud, but also the data that's local to your client. And I think what's emerging is a new stack. And to me, the three legs of the stool are React, Apollo, and TypeScript, right? A system for managing your user components, a system for managing your data, and a foundation underneath that gives you static typing end-to-end through the stack. And what we want to show you, and Peggy's going to walk through some examples of this, is how productive and how powerful, and frankly, just how fun an environment built on these three ideas can be. An environment where I have a set of reusable components. I have a way to describe their data requirements. Instead of writing all this code, I don't need to write Redux state management code. I don't need to write data fetching code that calls REST endpoints. I just describe what it is that I need. And a type system so that all that stuff is governed by build time checks, all the way from your underlying services all the way up through your UI components. We found that's a phenomenal combination. This is what a lot of the teams we've worked with are adopting, and we want to show you some of the really exciting benefits of going down that path with tooling and just some of the latest and greatest in the JavaScript ecosystem. Okay, so that's what we have. We've also got some amazing talks from people in the Apollo and the GraphQL community. We're really excited to share some of these ideas. As I said, the biggest thing here is for us to learn from each other. So during the break, after the conversation, please do chat with us, chat with each other. As I said, it's a new technology. We're really excited. It is the right answer, I think, for some of the challenges that product teams are facing today. And we're going to build it together. So thanks very much. And let me introduce James to talk to us about federation.